In this episode, we'll explore the role of tokens in CDK deployments. Tokens represent values that are unknown until Terraform applies their configuration. These values can only be resolved at a later time in the lifecycle of an app. An important thing to remember about the tokens is that they can be used to cast attributes of the token object to the correct type. Tokens represent values that can only be resolved at a later time in the lifecycle of an app. AWS provides an example of using a token as a placeholder for a bucket name. Names of resources defined in the app are only allocated when the code template is synthesized. A token is a placeholder for that yet unknown value. CDK encodes a token whose value is not yet known in construct time, but will become available later. Those tokens can be passed around as if they had encoded value. Tokens are objects that implement the resolvable interface, which contains a single resolve method. The CDK calls this method during synthesis to produce the final value. Tokens participate in this process to produce arbitrary values of any supported type. Other functions typically only accept arguments of basic types, such as string, list, and number. To use tokens in these cases, we can cast them into one of these types using static methods of the CDK token class. This is an important note. If you attempt to pass a string to extract a value from it, and the string is an encoded token, your passing fails. So any attempt to validate the value of unresolved tokens leads to undesired results. To check whether a value has an unresolved token in it, call the token, in Python, is_unresolved method. We have already seen the use of tokens when passed the ECS task role defined in the myIamStack class via the config_iam object as an argument referencing this object, which via the config_iam class here is being passed to myStack. The passed ECS task role is being passed then to the constructs in the myStack. This role isn't known until after the project via IamStack is deployed. CDK uses tokens for this, and it uses it implicitly. We didn't specify this argument as a token object. HashiCorp offers an example of token use. It shows how the subnets list is passed to the EKS construct. It is passed as a token object, cast to a list. In this example, because of the underscore, this is an output of the VPC HCL module. This is an example for this use case. We pass the subnets list defined in the VPC object to ALB objects in here. We didn't have to specify the VPC.subnets as a token object. CDK did it implicitly for us. The subnet's IP ranges are calculated here, and it is done during the deployment. Their values are not known before the CDK deploy run. So until the deployment, the values of vpc.subnets are encoded placeholders. So this is a token object. This can be explicitly stated by inputting the token here and defining vpc.subnets as a token object cast to a list using the s_list method. This is a token here. We have explicitly defined VPC subnets as a token object and cast it to a list. Let's check the syntax. No errors, great. Let's deploy the project-wide stack. Let's see what is being deployed. The listener. And the LB itself. And these are the subnets, known after apply. Let's apply it. Project Y is successfully deployed. It worked.